Hello everyone, welcome back to ANR Academy. Today we are going to discuss number of asymmetric relations from given set A to itself. The formula to find number of asymmetric relations is 3 power n square minus n divided by 2. Before going to prove this result, let us see how can we define asymmetric relation. See the definition. There is a relation which is defined from A to A itself. It is said to be asymmetric. Here the condition we have, if order pair x comma y belongs to that relation, implies y comma x does not belongs to that relation. For all x comma y belongs to given set A. This is the definition of asymmetric relation. We know symmetric relation. If x comma y belongs to R implies y comma x also belongs to R. But in case of asymmetric, y comma x does not belongs to R. For example, there is a set A that contain entries 1, 2, 3. And we know that A cross A that become with entries 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. These are the entries in A cross A. We know that every subset of A cross A is called a relation, and from those we have to verify asymmetric relations. I am going to write different relations. Suppose that R1 is a relation in which if I select 2, 1, that is one order pair, then 1, 2 does not belongs to that relation. So if you select 2, 1, there is no chance to select 1, 2. So that next, if I select 3, 2, then there is no chance to select 2, 3. And if I select, for example, 1, 3, there is no chance to select 3, 1. Yes, it's a symmetric pair 1, 2 does not belongs to this relation. Second element 3, 2, and for which its symmetric pair 2, 3 does not belongs to that relation, and 1, 3 for which its symmetric pair 3, 1 does not belongs to this relation, and hence it is asymmetric. And clearly there is no chance to select elements from principal diagonal. Why? Because if you select 1, 1, then by writing reverse, again it become 1, 1. So if 1, 1 belongs to that pair, after interchanging coordinates x and y, again we get 1, 1, that is belongs to that relation itself. So that is not asymmetric. So in asymmetric relation, there is no chance to select principal diagonal elements, remember. And other than principal diagonal elements, remaining here 6 order pairs are there. If you select one of the order pair from lower half, corresponding symmetric one doesn't select in this relation. So the clear observation, if you select one of the pairs from off diagonals, that is non-diagonal entries, then its symmetric term does not belongs to that relation. Yes. Next. So this is the basic definition. I am going to write another example also. Here 1 comma 2 is selected. Now I am going to select 2 comma 1 selected. Now I am going to select 1 comma 2. If I select 1 comma 2, no chance to choose 2 comma 1. Next remaining chances I am going to write 1 comma 3. Next 3 comma 2. Yes, its symmetric pair 2 comma 1 does not belongs to this pair, does not belongs to this relation. 3 comma 1 no chance, 2 comma 3 no chance, so that it is clearly asymmetric. Now another example I am going to select. Just I am going to write 1 comma 3 and 3 comma 2. The respective symmetric pairs does not belongs to that relation, so that it is asymmetric. Now let us see how to find total number of asymmetric relations from A to A itself. There is no chance to choose principal diagonal entries. So total there are n square elements. From that we are going to remove n diagonal entries. Next, upper half contain total n square minus total n square, and upper half lower half n square minus n divided by 2. Remaining n square minus n, from which upper half n square minus n by 2, lower half same n square minus n by 2. And the chance of selection, total there are n square, but chance to select pairs from n square minus n elements, remember. Why? Because there is no chance to select pair from principal diagonals. Principal diagonal entries, no chance. Total actually it contains n square elements. only the selection here pairs from remaining n square minus n entries, and in which upper half n square minus n by 2, lower half n square minus n by 2. Yes, suppose that if you are going to write a relation which is asymmetric, then the chance of occurrence of pairs I am going to observe. See, there are 3 different examples, R1, R2, R3, which are clearly asymmetric. Suppose there is an entry 2 comma 1 which is from lower half, and the remaining order pairs you have here. So in R1, in relation 1, 2 comma 1 is belongs to that relation, but in case of R2, it's a symmetric pair present in the second relation, and there is no 2 comma 1 and there is no 1 comma 2. So from lower half, if you select one pair, the pair must be in the relation, or the pair may not be in the relation. From these 2 examples, here you have only 2 comma 1. In one relation you have one of the pairs from lower half, and in the remaining 2, what you observe, there is no 2 comma 1, and the chance here in the remaining, maybe its symmetric pair present in the relation, or both does not belongs to that relation also. In case of all asymmetric relations, what you write, R1, R2, R3, R4, R5, R6, whatever the possibilities, if you write all the possibilities, just observe here, if you select one distinct pair, if you select one pair, that is 2, 1 and 1, 2, if you select one pair, what is happening? Maybe 1, 2 present element from the upper half, or element from the lower half, or there is no elements containing in that relation. So how many chances are there for selecting pair from non-diagonal entries? There are 3 chances. In case if you select another pair 3, 2, 2, 3, let us observe. Here you have 3, 2 present in all the relations. You may create one more relation, just 1, 3. Here you have 3, 2, 3, 2, 3, 2. So in the second pair, there is a chance to select 3, 2 in asymmetric relation. It is also asymmetric. Why? Because its symmetric pair 3, 1 does not belongs to that relation. So maybe 3, 2 present in all the relations. If you observe, maybe it doesn't contain 3, 2, or maybe its symmetric pair may be present in the relation. Suppose if I write another relation, maybe that contain the entry 2, 3 and 1, 3. So if you select one of the pairs from non-diagonal entries, from these two, maybe one of them present, one chance, maybe another one present, another chance, maybe both doesn't present in the relations, and maybe both doesn't present. If both present, then it is not asymmetric. There is a chance to select one pair from lower half or one pair from upper half, or there is no chance. So for each and every pair, there is only one chance from upper half, one chance from lower half, and nothing can be selected. So how many chances are there? Total 3 chances for each pair. Total there are other than diagonals, how many entries are here? Total n square minus n. Yes. How many pairs are possible? Total n square minus n divided by 2. N square minus n by 2 pairs. Lower half 1 entry, upper half 1 entry. Such pairs you can select. Such pairs are there, n square minus n by 2. In this way, you can select n square minus n by 2 pairs. And from these 2 pairs, the selection of entries for which there are 3 chances, maybe only one of these 2 present in the relation. So maybe this one or that one, maybe from lower half or maybe from upper half, or without this pair you can frame asymmetric relations also. So it is true for any pair. So for each pair there are 3 chances, remember. So for first pair 3 chances, for next pair 3 chances, another pair 3 chances, like that. Last pair also having 3 chances. How many 3s are here? total there are n square minus n by 2 pairs, half from lower triangle and half from upper triangle. Yes, total how many 3's are here? N square minus n by 2 3's are there, so that I can write 3 power n square minus n divided by 2 is this result, and it indicates total possible number of asymmetric relations. Just by observation, it is very clear, whatever the relation you have that is asymmetric, whatever the asymmetric relation we choose, in the pair of entries, maybe one of them present in the relation or may not present in the relation. How many such type of possibilities are there? Just there are 3 possibilities for each pair, and total there are n square minus n by 2 pairs. From lower half n square minus n by 2, automatically pair means it's a symmetric one, you have to choose in the upper half. So total there are n square minus n divided by 2 pairs and the pairs may not contain, one of them contain. One of them contain means there are 2 chances, maybe from lower half or from upper half. So total how many chances are there? 3 chances. So for each pair there are 3 chances. Like that there exists total n square minus n divided by 2 pairs, so that 3 into 3 into 3 into 3 n square minus n by 2 times gives the result 3 power n square minus n by 2. It is the formula to find possible number of asymmetric relations when a set A contain n entries. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.